Hi. Now that we've mastered a second order differential equation with constant coefficient and constant term, we can start applying our knowledge to economic problems. And the first one we're going to deal with is market model with price expectations. Okay, so what we're going to do now is that we're going to extend the model that we've done in Introduction to Economic Analysis, typical static model. Then, if you remember, during dynamic economic analysis, we expanded this model, we added dynamics by introducing a price adjustment. Now we're going to go one step further and we're going to introduce price expectations into the model, and we're going to see what's going to come out. And look, in this particular case, we will be assuming that our customers are following the price that is on the market, and they observe two main things. So first, when they observe price trend, they want to know whether the price is increasing or decreasing. What gives us information about it? Of course, first derivative, right? dp dt or p prime, right? So from this derivative, we get the information: is price increasing or decreasing? But look, the sole fact that the price is increasing or decreasing is not the full information we would like to have. Because, we can have a situation where the price increases, but it increases slower and slower and slower. However, it can increase faster and faster and faster. To get this information into the model, we need to assume that customers also look at the prices, look at the second derivative. So, we will get information from d squared p dt squared, or PBs, is price increasing or decreasing at an increasing or decreasing rate. Okay, so basically the participants, the agents within this model are looking at price trends, and they are trying to see whether price is increasing or decreasing, and whether this price is increasing faster and faster, or slower and slower, decreasing faster and faster, or decreasing slower and slower. All this information we will have in those two derivatives. Okay, so now that we know what these two expressions, what type of information they are bringing to the table, let's write down the model. Okay, so as every market model, we need to have quantity demanded, and we're going to be modeling expectations on the demand side of this model. So we will have a very similar model to what we had. So this is alpha minus beta p, right? Look, that was our old model, right? We've introduced dynamics to it, but for now, let's just say that we're going to introduce dynamics here differently. Of course, first, and second derivative. The dynamics are going to be associated with expectations. Okay, so we're going to add here m times p prime and n times p base. Okay, so now we've introduced first and second derivative into the model, and we've got some coefficients on them. Okay, let me just say that supply is going to be the same supply as we always use, nothing new here. So this is negative gamma plus delta P. Okay, but what do we get from these coefficients that you see over here? So for now, let's just focus on m. And once we've dealt with some part of a problem here, we're gonna think about n. But let's start with m. Look, what means that m is positive in our case? Look, if m is positive, this means that if price goes up, what happens to quantity demanded? Quantity demanded goes up as well. This is definitely against the law of demand, right? However, remember, this connection here is associated with the first derivative. The first derivative here is associated with expectations. So when m is positive, it means that when customers expect price to go up, quantity demanded will go up as well. Why would something like that happen? Does it make sense? Well, imagine a case like this. You are buying, let's just say, gold. And you see that today 1 ounce of gold is worth, let's just say, $1,000. And the next day, okay, this is going to be a ridiculous example, but let's just say it goes up to $2,000. Might there be a reason why would you like to buy this gold now? Well, of course, if you expect that the price of gold is going to be $3,000 one day from now, you can buy the gold for $2,000 and sell it for $3,000, right? So in this case, if m is positive, it means that the customers or participants of the market expect for the price trend to continue. If you expect it to continue, it's better to buy more now, because if it's you can sell it for more later. Okay, now, what if m is lower than 2? Look, this means that if price goes up, the quantity demanded will go down. Right? This is the law of demand. This is what we've got over here, right? But again, we are making the conclusions based on coefficient and expectations. So how would we explain this? Look, if you see, for example, that price of gold is 3,000, yesterday it was 2,000, why wouldn't you buy more gold? What if you're afraid there's going to be price reversal and the price of gold will go down to 1,000? This is what we get from negative m. So look, if m is positive, it's like price trend will continue. Right? Customers, agents expect the price trend to continue. If N is negative, it means that customers, agents expect price reversal. So it's gonna be, instead of increasing and increasing, we expect that this increase is gonna stop and the price is gonna start dropping. Okay. Knowing this is enough for us to carry on, because look, we're gonna be doing this model on case basis. And there's plenty of cases here. So for now, this is enough for us to carry. Okay. And what do we get? Look. First, let's solve the model. So quantity demanded equals quantity supply. Yeah, let's equalize them. So we get that this is alpha minus beta p plus n prime plus p prime and p equals to negative delta and negative gamma plus delta p. Okay, so now our endogenous variable is of course p, right? Price. So let's put all the endogenous variables with price to the left hand side and everything else to the right hand side. What do we get? Let's change the order just like we like to have it in case of differential equations. So I'm going to start with n b's plus n pi prime plus, and look, we've got negative beta plus delta. On the other hand side is going to be negative delta. So we can write that this is minus beta plus delta. And this part, this alpha goes to the other hand side, so it's going to be negative. So we can write that this is minus alpha plus gamma. Okay, and look, before we can start working with it, we need to do one more thing. Let's divide both sides by n. Because look, in every formula that we used, we never had any coefficient on the highest derivative. So we need to get rid of it. And look, what we get? We get b's plus m over n p prime minus beta plus delta over n. Oh, of course, p over here, I missed it. P equals to negative alpha plus gamma over n. Okay, and what do we have over here? This is actually the differential equation that we know very well. Look, this is y, b's. Then we've got plus. This is our a1. This is our y prime. Then we've got minus, right? With this, so we can put it collectively that negative negative beta plus delta over n is our a2. Y is p, and this entire thing is our b. Okay, knowing this, all we have to do is to apply the formula, right? So first thing we need to find is equilibrium solution, so particular integral. PP in our case, right? So this is b over a2, which amounts to, okay, let's do it slowly, negative alpha plus gamma over n, multiply, right, because we divide by the reciprocal, so multiply by negative n over beta plus delta. Minuses cancel each other out, right? Ends cancel each other out, and we get the equilibrium solution is alpha plus gamma over beta plus delta. And I hope you can see that actually this is exactly the same result we were always getting for equilibrium. But of course, this is just particular integral. We know the equilibrium solution, which is given by intersection of supply and demand. However, we don't know anything yet about the dynamics over here. So let's talk about these dynamics. Okay, and let's consider possible cases. Well, first case is of course real repeated, real distinct roots. When we have real distinct roots, well, if a1 square is bigger than 4a2. Okay, in our case, we know that a1 square, a1 is m over n, right? So m and a1 square is just simply m n square, right? a2 in our case is negative beta plus delta over n. So we get that 4a2 is simply negative 4 beta plus delta over n. Okay, so in the first case, we assume that this is bigger, right? We do not know the exact values of the parameters. We're just assuming that they are bigger. So look, but if this is the case, we can easily find the solutions. Remember, R1 and R2 is equal to, okay, I'm going to write it like this. 1 over 2 negative a1 plus minus square root of 4a, a1 square minus 4a2, right? We know that this outcome is bigger than 0 because we are assuming that this is this condition is met, and our solutions are 1 over 2 negative a1 plus minus negative m over n. Negative m over n plus minus square root of m over n square minus 4 beta plus delta over n. Okay, and of course, in this case, we will have that complementary function is given by a1 times e to the power r1t plus a2 e to the power r2t. Okay, so this would be the case number 1. Now, how will the case number 2 look like? Case number 2 are, of course, real repeated roots. So this is the case when a1 square is equal to 4a2, or in our case, that mn square is equal to 4 beta plus gamma over n. And look, in this case, we've got just one repeated solution, and this is negative a1 over 2, or in our case, negative m over n over 2n, and complementary function is given by a3 e to the power rt plus a4t e to the power rt. Okay. consider is possibility number 3. So the case of complex roots. Okay, okay. So case 3, complex roots. Okay, in case of complex roots, of course, we now have the situation that a1 squared is lower than 4a2, which in our case means that m over n squared is lower than negative 4 beta plus delta over n. Now, if this is the case, of course, we've got complex roots, so our roots are in the form of h plus minus vi, where h is simply negative m n negative m over 2n, and h is square root of 4 beta plus delta over n minus m over n squared. Now, if this is, of course, if we've got complex root, then complementary function is given by a5 e to the power ht times a5 cosine vt plus a6 sine v. Okay, so now that we've got all of this together, we can start. So we haven't said much about n now. Well, n is the parameter that is going to tell us whether a trend whether this increasing trend that we've got in price is going to increase further and further, or maybe it's going to die out, right? So now our expectations are, this parameter is not talking us about the expectation whether it's something going up or down, but rather whether it's going to increase faster and faster or slower and slower. And now let's consider different cases. Let's start with n being bigger than 0. Okay, look, if n is bigger than 0, we can rule out two cases right away. Why? Look, if n is bigger than 0, right, we see that 4 beta plus delta over n, this is positive. It has minus up front, it can never be bigger than case where m over n is in squares, right? We cannot have negative number out of expression in squares. So case 3 in this case can be eliminated. Now, how about case 2? Look, it's always also impossible. I'm sorry, I'm messing the minus here. Case 4 is also impossible because we know that all those are positive. So again, this expression on the left is positive definitely because it's in squares. It has minus up front. This case is also impossible. So the only possible case here is actually case number 1. And look, what do we have in case number 1? R1 R2 are equal to 1 over 2 negative m over n plus minus m over n squared plus 4 beta plus delta n. Okay, look. This is a very specific case where we can get a lot of information, but we need to figure it out. Look, imagine for a second that there's no this part under the root. This is then equal to square root of m over n squared, which is m over n, right? Just like here. Okay. However, there is another expression over here that is positive, right? So we are not subtracting it from this number. So let's call it that here we've got m over n plus some x. Okay, what does this mean? Look, if I put our outcome on the axis, I didn't make any assumption about m. So this m can be either negative or positive. Actually, it is inconsequential. What am I talking about? Imagine that those are our roots, right? If the roots are negative, both negative, we've got dynamic stability. But if at least one of the roots is positive, we've got dynamic instability. So look, I'm putting here, let's for now forget about this. This is inconsequential. I'm putting this negative m over n somewhere here. Let's just say that here we've got 0. Right? And let's just say that this negative m over n is negative here, right? Now, what should I do to get my roots? Okay, we forgot about the 2 up front. Well, I need to add and subtract this. So, first case, we subtract. So I subtract a number. So here I will have negative m over n minus m over n minus this extra x, right? But then, what is going to happen? I'm gonna add, right? So first, when I'm gonna add to this number, I'm gonna add m over n. I'm gonna be at 0, but then I'm also gonna add this special part associated with that we call x, and I'm gonna end up somewhere over here. So look, in this scenario, we see that model is dynamically unstable. So first we notice that actually under assumptions we've undertaken, cases 3 and 2 are completely impossible. But even if the possible case of repeated distinct roots prevails, still we've got dynamic instability. What is the economic interpretation of this? The best way to think about it goes in the lines of what I'm going to tell you right now. So, let's just say the trend is up, right? And everybody expects that the trend is up, and everybody expects that the price is going to be increasing faster and faster and faster and faster. What is the rational thing to do? Buy the good, sell it later. So, we will have extreme demand for this good, and the bigger demand, the higher the increase in the price level, right? So, price will be becoming higher and higher and higher, people will be buying because they are expecting that the price is going to rise even more and more and more, and the market becomes unstable. We've got a bubble and price is increasing without a point. Of course, in real life, at some moment the bubble will burst and a lot of people is going to be in big pain. However, those of them who are actually able to sell at some point, which of course in this case is not a very rational thing, because if you expect that the price is going to increase tomorrow and it's going to increase by more than it increased today, what motivation do you have to actually sell it? So there's just buying and buying and buying, and price goes up. Okay, so now that we've got a case of n bigger than 0 done, now let's move to the case of n being smaller than 0. Okay, so now, what if n is lower than 0? Okay, look, if n is lower than 0, then what do we have? M over n squared. Of course, this is still positive, right? It's in square. But now, negative 4 beta plus delta over n is also positive, right? So we've got here two positive numbers, right? Because with n being negative, this minus and this negative n cancel like each other out. We've got two positive expressions. So here, actually what we need to do is to dig deeper into possible cases that we can have. So now, let's turn into n. So what if n is lower than 0 and m is lower than 0? Look, we see over here that if m is lower than 0, again we can have three different possible cases. Well, but let's look deeper into these cases. Look, we've got under this real distinct roots, right? We've got that m, negative m over n, is bigger than 0. Oh my god, sorry, it's smaller than 0. However, it is bigger. However, we get that m over n, of course in this case, squared, is bigger than 4 beta plus delta over n. Right? So, what does it tell us? Look, again, we can look into the same case. Look, if we know that this part is negative, right? We know that it is negative, and this part that we add and subtract is smaller than m over n, right? We are going to be again in this situation that here is 0, here we've got negative m over n, right? And now look, the number that we've got in the parentheses, again, I'm disregarding 1 over 2. We should have it in our solution, but this is not important here. Look, again, this number, m over n squared, is bigger than 4 beta plus delta n. But when we are subtracting it, right? Because we are adding it, but it has minus up front. So we know that we're going to get two roots that are going to be, they should be more symmetrical, somewhere around here. Right? We see that the bigger root is going to be still below 0, and the smaller root will definitely be below 0. So, what this implies is that in this case, we will definitely have dynamic stability. So, let's go now to case number 3. And case number 2. Here the root is given by negative m over 2n. Well, under these assumptions, with negative n, negative m, and minus up front, we know that this is negative. Again, we've got dynamic stability. And finally, in case number 3, which is also possible here, h is given by negative m over 2n. It's negative. Again, we've got dynamic stability. Okay, what is this telling us? So look, if we have a situation when customers are actually expecting price reversal, remember, price reversal, the market is going back to equilibrium. And look, it makes perfect sense when you think about it. You observe that the price is going up, right? However, people realize that this high price is unjustified, right? So they expect for the price to go down. What do you do if you expect for price to go down? You sell. If you sell, you drive price down, right? If you want to sell, it means you increase supply. With increased supply with the same demand, lower price. And this is what happens. If we will have price reversal assumed by the market participants, we will actually see that the price will go back to equilibrium. Okay, and of course, the last case that we've got over here, is the case where m is positive. But look, so if m is positive, we can still have three cases. However, look, in case of C1, negative m over n is bigger than 0. In case 2, again, let's put it with 2, and negative m over 2n is bigger than 0 in the second case. And in case number 3, where we talk about h, not r, like here, h is also negative m over 2n, and it's bigger than 0. So, regardless of the case under which we are, we will have dynamic instability. Okay, so what does this imply? What does this imply to us? Well, as long as the customers are expecting for the price to go up, the market eventually will become unstable. Okay, I think that is enough for one time. Don't be surprised if you need to see this video again, because I know that there is a lot of information. Remember, you can read about this model in the book, although the book explains it generally but I've actually considered here all the cases and I explained here the things that are not explained in the book, so all the reasons why we get results like that. Okay, if you have any questions, you can of course ask, and you will be practicing this model on the actual cases with numbers with Valeria, so you will have a chance to familiarize yourself with that a little bit better. Okay, thank you for your attention and see you in the next video where we are going to discuss a Phillips curve model. Okay, take care.